button. Okay, good. Hello, everyone. We are live. This is PostgreSQL Open Talks series, where we invite great guests, great talks to redo great talks. Usually, it's a talk which is not recorded at all at some conference, but this time it was recorded, as I understand, because it was on FOSDEM, but not well distributed, I would say. And let me introduce myself. I'm Nikolai, and my co-host is Ilya.
Hi, everyone. Hi, Nikolai. Hi, Boris.
And our great guest today is Boriss Mejias. Am I right? Pronunciation?
Yeah, perfectly
good,
pronounced.
good.
Yeah.
Great. And we are talking today about JSON. I think like JSON is very, very, very popular feature in Postgres, and it's like a strength of Postgres. But before we switch to the presentation itself, as usual, I remind everyone, please subscribe. We have more than 50% of viewers who watch our materials without subscription. It's not fair. Please subscribe. And also, as usual, I would like to welcome specifically those who joined us online, because you have ability to participate. Please ask questions in chat. Ilya and I will be monitoring the chat and deliver your questions. We will not miss any of them. And of course, if you watch online, please leave questions in comments. We will be monitoring comments as well. And as usual, please like, and especially I ask, this is a great help for us. Please share content in your social networks and working groups. An additional ask today, we select talks, but if you have some specific idea of future talks, please also leave a comment or just reach me out or Ilya and suggest some speaker or talk. Okay, that's it.
Actually, I have a small idea. I still like 3 minutes from the talk as well. I'd like to mix our traditional Postgres TV format with our Postgres Open Talk format. So I have a small question to Boris before he starts. Like we usually ask some awkward questions to people who are invited to Postgres TV. So basically, how did you end up with Postgres? What's your story?
Okay.
Like so, instead of introduction.
That's a good one. So my first project is at the beginning of the century. It was in Chile. I'm originally from Chile. I live in Belgium now. I was in Santiago. I grew up in Patagonia, but I went to the capital city to study to become an engineer. And I was a classmate of Álvaro Herrera. Álvaro Herrera is one of the core developers. We are friends as well. And
classmate, you mean like at school?
No, in the same class in the university.
University, great.
At the university,
great.
Yeah.
Great.
So we in that university, in Universidad de Chile, we have to.
So it was bad company, bad influence.
So every summer we have to do 1 month of internship or something like that. That we do a job, practical thing, so that we get experience 3 summers before we graduate. And we usually work more than 1 month because the projects are always so fun that we end up in the whole summer like kind of doing some stuff, and then we take a few weeks of holidays. So Alvaro was searching for a front-end developer for a project that he was hired to do. And so somebody gave him my detail that I should be a good candidate, although we knew each other already from the courses. But he contacted me and he said that we are going to use Postgres. I said, okay. So I said, why Postgres? I had some experience with MySQL at the time. So because Postgres has transactions. I'm talking about 2001. So at that time, MySQL didn't have transactions at all, and Postgres had transactions. I was like, okay, fantastic. Let's learn Postgres and let's do something with Postgres. At the time, we were the only 2 programmers in the entire company. So there was a spin-off or a first project of the company, and the company still exists today and is much larger. It was a monitoring system for internet at the time, and Alvaro did all the stuff in Postgres with Perl scripts and C code, doing all the monitoring, and I was doing all the interaction with the database in order to show the graphics and to do the nice part so that the users could interact with the information in the database. So that was the first project in 2001, and it was really fun. A lot of stuff, especially because at the time we were testing things like pulling out the cable so that the server really crashed, and looking at the database was crash safe. Very, very nice stuff. And after that, I went to academia. So then I came to Belgium, did a PhD, and Alvaro carried on doing Postgres, and that's how he became then one of the core developers. So
is your PhD related to databases, or
sorry?
Is your PhD related to databases?
I did a PhD on decentralized system, this is distributed system, peer-to-peer self-management system, and I did key value store. So very similar to MongoDB actually, and with transactional operations. So you could do key value storage with transaction operation in a decentralized fashion. So sharding and majority. At the time, Paxos was the algorithm that was the most interesting for doing majority instead of a two-phase commit, which actually brings me to when I came back to Postgres. So I was doing my PhD and I was doing all this storage and peer-to-peer, and I needed to implement two-phase commit and Paxos to do a comparison between the two and which one was working better for peer-to-peer. And I was in FOSDEM and I saw that Heikki Liinakangas, he was presenting about two-phase commit in Postgres. I said, well, I would like to see some Postgres stuff again. This is, I think, 2008, 2009. I don't remember. And I went to see the presentation, very well explained. And I talked to Heikki and said, but I will send you the link to the code so you can go and look at it. And actually, I could understand a lot on the code, even though I didn't. That was my first approach to Postgres code in the core, and everything is very readable. The quality of the code is really, really good. And it was fun to see that in the header, the code was implemented by Heikki Liinakangas and Alvaro Herrera. So the circle was kind of close again. And I said, okay, well, I need to do some more stuff. I'm going to probably start using Postgres again. And then I implemented the library for the school of my wife. So the library is still running. It's an open source project and everything is in Postgres there. So, and then once I finished the PhD, I started to work with Postgres stuff, and now I'm 100% with Postgres. Now, the good thing is that in my job, I'm doing multi-master stuff, which is kind of close to peer-to-peer because you have multiple writers and you also need some consensus and stuff. So plenty of the stuff that I did in PhD.
We have high risk of diverting from our main topic today because multi-master with like, I mean, it's not your fault. Like I'm like have many one question Ilya started triggered more questions. So multi-master we're using what? Multi-master using what?
Postgres, everything is Postgres, and
just logical decoding and some custom solution. So not exactly. BDR, no. Okay.
BDR actually, yeah.
BDR actually. Okay. BDR. And what do you think about it?
Well,
in general,
I enjoy all the project, and the good thing is that by having all this knowledge that I had with peer-to-peer stuff, also I studied MongoDB. The main thing is that when you are a developer, you need to understand that scaling out horizontally is not a transparent thing. It's not something that, oh, let's add more servers and this is magically going to have multiple writes and everything is going to be synchronized.
I thought you actually write to all the nodes simple JSON without any schema and you win. Yeah? So
that would be one way of doing it. In fact, this is one of my examples in the presentation. Yeah.
Okay, I probably will talk to you later about BDR.
That's a clue why we need to invite Boriss to normal Postgres TV to talk about the things more. Yeah, let's do it at some point.
Let's switch to the presentation. Otherwise, it's good. Too much. Good, thank you.
So let me share my screen, and I'm going to also.
I can see it.
Yeah, you can see JSON in PostgreSQL. So learning with a case study. So this was a presentation that I gave in FOSDEM. It was a 30 minutes presentation. Since here in this series, we have a little bit of more time. Instead of having one use case, I have two use cases. So learning with two case studies. I'm an air guitar player. That's my main activity. And for fun, I'm also a solution architect at EDB. In EDB, we work with BDR, and as Postgres distributed is one of the things that I like a lot because it involves multiple write nodes and decentralized systems, basically. If you want to ask questions after you have seen the record, because you can ask right now directly on the chat, but if you're just watching the recording, you can always contact me through Twitter on Chorix, yeah? And then I will reply promptly. Okay, so the presentation is being adapted for PostgreSQL especially, so it's not the same thing as in FOSDEM. So there are a few extra things that are added. The first thing that I added is actually the first use case, which is document management system. What I was telling you, I was doing a PhD. After the PhD, I did some stuff with Alfresco, which is a content management system. It is something like Microsoft SharePoint, or maybe you can even compare it to Google Drive and stuff like that. When you have people that goes to a server where you share documents between your organization. Alfresco is a commercial open source, and because it was open source, I wanted to be there involved. And one of the databases that is well supported by Alfresco is Postgres. So then that was my main motivation to work there. So the reason why I mentioned this is because when you have metadata to organize your documents, the main thing that you have is an ID for identify where is your document, and every document has a name, it has an owner, it has a moment that it was created. Sometimes it also have a moment when it was modified, and it also have a size and a type. So that's typical thing that you put in a table. Yeah. So your table is going to reflect all these attributes of your documents, and every document is going to have this information. Now, this works for many types of documents, especially text, Word documents, or spreadsheets, and all those kind of stuff. But of course, you don't want to do only that, and you're going to start putting other stuff like images. So if you add images, you probably need to have some other attributes like the height and the width of the image. So you need 2 extra columns that is going to be used only in some cases. In some other cases, it's going to be a value of null, because some documents don't have those properties. But if someone wants to have a picture that it was taken in a very special place, it would also like to have some geographical information like latitude and longitude. But those 2 are not going to be in all the images. But you start extending your attributes of all the documents. But then, of course, some people from the marketing organization want to have some videos, and then you're going to have frames per second, the length, or the audio reference, and your table start going very, very, very large. Imagine if you then add things like AutoCAD documents or ebooks, where you have pages, the ISBN number, IBSN number, I don't remember exactly, but you have more and more. So what you would end up is that you have one area, which is always filled in, the ID, the name, the owner, and some other really wide part that is filling only in some places. And you don't know how many more you need to add. So this is solved by splitting your core data of your document plus your attributes, which are going to follow into a pattern called the entity attribute value. Yeah, so this is something that is being used multiple times in order to have a wide, almost empty table. You split it into a vertical table where you're going to have in the middle either a value which is going to be a string, or a numeric value, or a Boolean, for instance. And then the value is going to be identified by a property ID. For instance, that could be the height or the width of the document, or the latitude location. You're going to identify that with a property. Yeah, so you're going to say this value that I have here, it is actually this type. And then you have your document, which is a foreign key pointing to that document. That means that one single document is going to have its attribute spread across the entire table. And the table is very, very long. So you can see here, so you have the 3 dots there. And this is how it's solved. It's a pattern. But this pattern is a workaround to the limitation of having a fixed amount of columns per table. That is when you want to have all this part there outside as a JSON object. Ta-da! So this is why you need JSON, actually. You don't need JSON to replace columns and replace the entire relational model. You don't want to have the other extreme with MongoDB, for instance, at least in this particular case. But you don't want to have all this complicated pattern. Just put a JSON object there. You identify your core, and then you have a JSON object. And the JSON object is going to be the dynamic part of your data. Yeah, that's why I think it's useful. And actually, this part can be a little bit more to the left if you want. You can put maybe the size and the type there inside. It's up to you how you manage that. So it gives you the possibility of designing this in a different way. So what is JSON? Do you know what JSON means? Actually, this is a question for the presenters.
JSON means format, special
It's a
format,
but it's a special format. It's a JavaScript object notation.
Object notation, right.
Yeah, yep. But it's from JavaScript, so it comes from a language that is not so popular in some areas, but very popular in all others. It doesn't matter. It is a contribution that comes from JavaScript.
JavaScript and SQL are two of the most popular languages, right? Because JavaScript is installed in any browser and SQL is used in any application. Well, in many, of course, there are non-relational databases, but they are like a kind of hidden languages, right?
Exactly. The difference is SQL is very structured and it gives you a lot of guarantees, asset properties and stuff like that. Whereas JSON is very dynamic, even in terms of typing and in terms of things that you can do. So I don't like going into none of the two directions. I want to have a combination of the two and hopefully getting the best of each of them and not getting the worst of each of them when you do a combination. Okay. So let's do some examples. So a JSON object look like this. So you have a way of building your object, which is going to be composed by key values. Yeah, so you have a key here, a field, height, and then the value, which is 800, and then you can have multiples of those. And this is an image, which is just the size of the resolution of the image. This other one is a little bit wider and longer, and it has a position also, latitude and longitude. Okay. So another one here, this one is for an audio. So you have a container for the audio, which is OGG, open source format for audio. And then you have a duration is 7 minutes and 56 seconds, sorry. And then you have tags. So you can also compose your JSON object with arrays. And this array contains strings. So you can see here for the tags, there is an interview of Slonik, the elephant, which is part of the Postgres community. So you can put whatever you want. And this actually removes you from that limitation that you have with this attribute that you didn't know which was those attributes. I'm going to come back to the format, but the important thing here is that in this case, you have these things that are spread everywhere, whereas here you just put them in one column. Everything is in one column. You don't need more than that. Just say, well, I have a column which is JSON, and then you get it. Good. So getting now back to Postgres implementation, we do have two data types, and this is important to make the distinction. One is just JSON, which was the first one that was supported, and the other one is JSON-B. Yeah. All the languages has like database systems like MongoDB has BSON, which is binary representation of JSON. But in Postgres, we do elephants, so we couldn't use BSON, so we use JSON-B because it's the best representation of JSON. That's the B what it means. It doesn't mean Boriss, it means JSON best or binary. Or Jason Becker. Jason Becker is a really, really good guitar player. He cannot play the guitar anymore because he has an illness. He's a
Or just it was a plan B to implement JSON and Postgres.
What?
It was a plan B to implement Postgres, JSON and Postgres. Yeah, first was JSON implemented.
JSON, that's just plan B. But if you forget which one it is, you think about good guitar players and you remember Jason Becker. Say, that's Jason B is the one that I really want to have. So a metal guitar player from the 80s and 90s, then he's just composing music and some other guitar players are playing his stuff. A good friend of mine, Jonathan Gonzalez, another Chilean, he is his birthday today and he's a fan of Jason Becker. So I wanted to take the opportunity to wish him happy birthday. So Jonathan, when you're watching the recording, happy birthday. So JSON-B, JSON as JSON. And here I'm going to talk a little bit about the types that you can have in the JSON objects. It can be a string, as you can see for the first name, last name, or it can be a number. The number can be either an integer or a floating number. Everything is just number, okay? But it can also be a Boolean. So is Jason Becker awesome? Yeah, true, it's a Boolean. Those are the basic three types: strings, numbers, Boolean, that's it. And you can also have a composition of those in either objects, which will be the entire object here, or arrays. And in the arrays, as you can see, I have here, for instance, the bands that Jason Becker has played, Cacophony and his own work, Jason Becker. but also I can have an array that contains another object, which contains an array as one of the values, because he have done collaborations with Marty Friedman and David B. Roth. So this one gives you actually a lot of potential to do whatever you want as soon as you respect the JSON notation. Of course, you can also have null values in a JSON object. In this case, I express it to say that there is no at all relationship between JSON Becker and reggaeton. Which is a good thing. Actually, everything that is null in JSON, I will say that you just get rid of it because you don't need it. I mean, because otherwise you can start filling in your JSON object full of null values where you don't need them. And in the end, you're going to have something that you want to give more structure, but that you don't need it because you just get rid of it. I mean, you just put what you need. This is what I like from JSON. If you really need to have a fixed amount of fields, then you use a table. That's what tables are, a fixed amount of attributes. Okay, so that's about the types of JSON. Okay, I'm going to come back to that a few times. So that was the first use case to justify a little bit the usage of JSON. I find one case that I think the best solution is actually to use a JSON object instead of using the entity attribute value pattern. Now, this is the use case that was presented in FOSDEM, is the heavy metal name generator. So if you have a band which plays heavy metal and you don't know how to call your band or how to call your songs, you just go to this website, which is called metalizer.dk, which is from Denmark, and you get random names. These are all randomly generated. Be careful, sometimes it violates the code of conduct, but you get heavy metal names everywhere, and then you can use them and all stuff. I tried to contact the guy to tell him that I use his material to do a presentation, but he's never to be contacted anymore. I mean, apparently he vanished from the network. Maybe he was taken by some church or something. I don't know. So it has an API. So we are going to build this API. The API gives you either XML. Sorry. Well, if you want to use that data type, and I'm going to mention it again, because every time that I say that word, I kind of cough. I prefer JSON on top of this other one. Okay. So you go to metalizer.dk API/JSON, and then you get any random JSON object representing a metal album. Or you can pass actually a valid ID, and then you're going to get it in JSON or the other formats. So how does it look like? Well, it's exactly like a JSON object, except for this function here that says JSON metalizer album. So actually the API shouldn't say JSON here if it's giving you a function. The object is actually from this open parenthesis to this close parenthesis here. Yeah. Let me show you another example, which is a little bit easier to read. So it has some ID. So you have the ID here. It has a year, which is put as a string. This could have been a number, for instance, but everything is put as text. The label is the Unsufferable Records, and the band is called the Harmonic Sin. Yeah, so really metal stuff here. You have songs like Between Bliss and Guilt. Yeah, so really metal topics. And then you have secrets here, which is another JSON object, which contains two fields. One of them, the value is an array. So I thought that this was kind of perfect to study JSON, because I mean, it gives you practice about how to use JSON. When I do presentations, I always try to kind of have the same approach that I do for learning, which is practicing a lot. It's like a Kiko Loureiro, one of the best current guitar players in my opinion. He also says that, I mean, if you want to learn, for instance, the pentatonic scale, just don't do up and down with the pentatonic scale and that's it. No, pick up some riffs from songs, play them, make some compositions with that scale until you really practice a lot with the scale, not just theory. So we're going to practice with these metal objects, okay? Right, so let's import all the things that I downloaded from the this metalizer.dk, and I put them into two tables. One table is just the object JSON. Yeah, I have one field in this table, which is called album, and another one, which is exactly the same. The only difference is that the plan B, as Ilya was saying, JSON B, and the type is JSON B. Okay, this is the binary representation, and it allows you to do a lot more things than the JSON representation, which is just parsing the JSON, telling you whether it's JSON or not, and that's it. So let's look at the storage, because a lot of people complain like, but JSON uses a lot more storage than regular tables. Well, at least in the database, it uses less storage than in files. So if the directory that I downloaded the JSON files uses 40 megabytes, after I put everything on the tables, it is less than 10 megabytes, which is a good thing. I mean, at least in the database, it's going to be less than the files. Yeah. Okay. So JSON in Postgres. Now I'm not going to refer to JSONB all the time, but JSON in Postgres.
So actually, we have a question in chat which is kind of related to that. So basically, what's the difference in terms of JSONB in Postgres and JSON implemented in our, for example, NoSQL databases? So what's the key difference?
Well, in the case of MongoDB, for instance, is the BSON, which is the binary representation of the JSON objects. It is built for the same reason that we have JSONB, because it allows you to index stuff in a much structured way and programmatic way, whereas the JSON type, it is just the object that is being stored in your database, and you keep it as is. So whenever you need to have an API, for instance, that returns something that is being put in place exactly the same way that you put it there, then you use JSON. But if you insert something and you convert it into JSONB, it's going to be rearranged. If there are some fields that are duplicated, it's not going to let you the two, it's just going to have one. And then when you return it, it might not be exactly the same order. It could be some different order, but it's going to be exactly the same fields and values. But it's going to allow you to do a lot more stuff. And the storage is also going to be a little bit more efficient. But let's see. So I do have this database called headbanging. Yeah. And if I show you the tables, I do have two tables. One is called metal JSON and metal JSONB. Size is kind of the same. Let me do select star from metal JSON and then limit 1. And you can see that the object comes as a JSON object directly. Okay. So this is your JSON object as I put it there. Same order, exactly the same. You can see it starts with metalizer, label, album. Exactly the same that I show you on the slide is there. Just pick up one random. Now, if I do it from JSONB, you can see immediately that it's compressed. And you can see also that the order of the fields is not going to be the same. Yeah. So this is exactly the same value, but it's kind of compact in a way. But you can always kind of see it in a better way. So in a pretty way. So JSONB pretty. Let me pass the album there. And I have it in a much better readable way. So JSONB pretty is going to give you a JSON object, a JSONB implemented object, but it's a JSON object in a much better representation. So you can read it. It's pretty for some interpretation of pretty, of course. Now, is there any JSON pretty? Yeah. No, there is not, because I mean JSON is already like that. I mean, it's already as pretty as it can be. What I could do, I mean that's what you get. I mean, this is what you put there. So this is your definition of prettiness. What I could do, it could be actually to this is metal JSON, to convert that album into JSONB, and then pass it to JSONB pretty, and then it's going to be much prettier. So I take a JSON object, I cast it into a JSONB, and then I pass it to the function JSONB pretty, and then I get a better representation. But you see the order of the fields is not the same. So that's one constraint. If you really need to have exactly the same object, then use JSON. For all the rest, use JSONB. I hope that answers the questions. All right, so JSON and Postgres, you saw already the first approach to JSON and Postgres. Now, how you access the fields inside JSON object. There are three main things that you can use here. There are multiple things, but I'm not going to show you the whole stuff. I mean, if we are studying music, I'm not going to show you all the scales because I mean, that would be too much. And we are going to focus into something that allows you to start working with JSON. And then the idea is that with this presentation, it opens a door for you to start exploring the whole stuff. Yeah. You have an arrow. You have an arrow that goes even further. And you have something which is kind of a funny arrow, which is a container, actually. What do you pass here? You always pass an object on the left side, and then you pass a field for the first one. And then what are you going to get? An object. Yeah, so that's important. If you go inside that field, then you get text. You're going to get numbers, you're going to get booleans, you always get text if you get that particular arrow. Yeah, so that's important. And then in this one, instead of passing an object in a field, you pass two objects, and you're going to say, is this object in the right side contained inside this other object in the left side? And then you're going to say yes or no. And that Boolean return is what you're going to typically use in a where clause. So give me everything where this object is inside my field containing that particular object here. Yeah, so like when you're searching for something, you can use this. Okay, so we saw in the objects, like you have an object that has several keys, like ID, year, album, and stuff like that. So we can return that. So this is the way of getting that. So the keeper of the 7 keys, like an album from Halloween, power metal band from Germany. Okay, JSON B, it doesn't work for maybe it does work for JSON, but JSON B object, and then is a keys. So we're going to get the keys of that particular object. So let's do it. If I do select JSON B object keys, and I pass an album, and then I'm going to say from metal JSON B and limit 1. Boom. Oh, no, that's not what I wanted to have. Just everything, because otherwise I'm limiting one value that I get from that particular keys. So I can see that I get all the keys from the first object, then from the second object, then from all the objects. Yeah, which gives me everything. Yeah, a little bit too much. So let's get a better query. I have here. That would be here. Here. So let's start already by saying that select JSON B object key. So give me the keys of the album field from this metal JSON B, where the album contains this other object here. So what I'm building here is I'm building a JSON object that I'm going to pass through this container to here. And if it matches that, then I'm going to give the keys of that particular object. So you can see the way of building an object is with single quotes, and then everything that is inside is your representation of your object. Yeah. So double quote for the fields and the text. So it finds one particular object, and it gives me all the keys of that one. Right. All right. So that's one way of getting the information. Now let's do the following. Now I'm not going to filter by anything, so I'm still going to get all the objects as we got the very, very long list. But what I'm going to do now, I'm going to group by key. Yeah, the key is going to be the value that I get here. And then I'm going to count them. Yeah, so how many times do I have an ID? How many times I have an album? Because you see that when we were looking at the first example, the object could have height and width. Some others are going to have height, width, and latitude and longitude. And then we will see how different are the objects inside my table. But in this case, I can see that I have exactly the same amount for each of the keys. So that means that all the objects are constructed exactly the same way. So then why do I need JSON? I could put this on a table actually, because all the objects has exactly the same attributes. So I could have this in a table with 8 columns. So this is one indication of whether you need to do these kind of things or not. Okay. Good. So let me show you the following, because I was telling you about this arrow. So let me do album, and then get the ID of that album. Yeah. And from metal JSON B. And then I'm going to do limit 3. So I get 3 IDs. And as you can see, what do I get here? It is something that looks like a text, but I told you that this is going to return, because I'm using one arrow, an object. A text like this is a JSON object, is a valid JSON object. A JSON object doesn't have to start always with a parenthesis and close with a parenthesis. It can be just a text as a JSON object. If you don't believe me, I can do here pg type of all JSONB. So it's important that this is a JSONB object, because sometimes I would like to compare this thing that I get into something. If I compare this to a string, it's going to say, nope, I cannot compare JSONB to a string. So if I need to have a string, actually, I need to use an arrow that goes even further. Yeah, so give me the text that is inside that JSON object that I just retrieved. And then I get only text. You see, that's a type of. So let's see what will be without the type of. Yep, so I get exactly the same, but you see the representation is slightly different. I don't have this double quotes here. That's text. That's a JSON object. So that's important to understand.
That's why converting to text is less convenient, because it will preserve double quotes, right? I mean, if you can just convert a JSON object to text using colon text, double quotes will be there, and it's not convenient.
Right. Exactly.
Compared to double arrow, right? Mm-hmm.
The double arrow is going to go inside and it's going to get the text. If this would have been like a year, then I could even convert that to an integer afterwards, because I know that those values are most probably an integer. Yeah. So yeah, so you need to do a lot of casting when you are inspecting JSON objects. So
we have a good question in the chat.
Yeah.
We have many good questions, but this one, like, good to interrupt. So, is there an official name for this arrow-like operator in JSON? So, just arrow in JSON, or it has some name?
I don't know, actually. I don't know whether it have a. The way for me to remember this is at least this one gives me the object, because I'm going to see the value inside that field, and the value is always going to be a JSON object, unless I want to see what is inside that particular JSON object. And when I go even further, I have a double arrow. So I'm going. That's my only way to remember it, but I don't know whether it has a name. If it has a name, that would be good. So
there's an unofficial name.
I always thought it's actually they run out of symbols and use something.
Yeah, it's true. Like this one, like the container here. Where's the container? Here, this one. I mean, that looks odd. I always need to search what is that, and I need to check my notes. But yeah, it's a container. All right.
Yep.
So that's important to know about the types and what you get. So if you want to get the keys, actually, you can always inspect this with the JSON keys. Yeah. So if you want, it's like, give me. If I want to have all the pictures, if I come back to the example of the document management system, give me all the pictures that has geographical information. What I would do is I would say like where I get the list of keys of that object, and I see that the longitude and the latitude are part of the list of keys. And then I will know which objects are actually images with a geographical location. Unless you have a type, which would be a next thing, but I mean, that would be one way of doing it. Okay, so we saw that there are some arrays inside the JSON objects, and we can also work with those arrays. And the way to work them with the functions, it is everything is start with JSONB. And then I get array, and then I can get the size of the array. What I pass, I don't pass an array, you see, I pass a JSONB as an argument, because an array inside is also a JSONB object. I can also get the elements of that array, or I can get the elements as text. Yeah, so you can guess that if I get the elements here, this is probably going to be also JSON objects. So if I want to have them as text, I do with this extra function here. Yeah. So let me see if I have an example of that one. No, I don't. But we can just. Yes, I do have. So yeah, look at this one. So I do have a field called tracks. Yeah. So in this case, I'm always going to be filtering by this. And I'm going to have this ID. We're always going to be working with the same album, and give me an array, yeah, which is all the tracks that are inside this field, yeah. Panzer misery, obscene demonstration of power. It's always fun to work with this stuff. Now, if I want to have the following, which is, you see, I got the arrow here. So I got a JSON object as a result. And if I put the text here, I'm going to have the same thing, but as a text. So this is not really an array, this is text. Okay, so PG type of. So it's text. It's not very useful to work with this because, I mean, that's a text. So to find something there in between, I need to parse text. And I want to work with elements of an array. If I have an array, I want to have working with elements of an array. So let's do it like this. Let's use one of those functions that we have on the slides. Ta-da! That's much better. I do have the elements there spread out in a column, and I do have the JSON array elements. Yeah. Let's see what is the type of those elements. Can I do it like this? I'm not sure. I haven't tried this one, so if it fails, oops, this is part of the practice. It's all JSON-B. See, all JSON-B. So of course, if I want to have the elements as text, what I need to do is I need to have this one here. Boom. Text. Yeah, and now I have all text. So without text, you can see that they have this double column. So that would be a JSON object. Can I cast this like this? I haven't tried this. Okay, so this is what you were saying, Nikolai. If I cast this, I'm going to have a text which contains the double quotes. Yeah. Whereas
yeah, it leads to many complaints from developers, like, oh, I need to convert it, and then sometimes it's like also escape, like backslash and so on. Like it's not convenient.
Yeah. So the thing is that this is consistent in the sense that this is a text representation of a JSON object. If I give you this is not a JSON object. This is a text, 3 words with 2 spaces in between. This text. Whereas this one is a JSON-B object that I convert into text. So what I'm expecting from this is a text representation of a JSON object. And this is a JSON object. This is a valid JSON object. It doesn't have to have the parentheses. So this is if I parse this into a table which expects a JSON, it's going to accept it. It doesn't have keys and values, but this text is valid. It's valid JSON notation. So if you check the JSON standard, it's going to say, yes, this is text. This is a JSON object. It's good. So that's the reason. It's a text representation of a JSON object, whereas this one is the text extract from within the JSON object. That could be a name for a track as well. Extract from within. Yeah. So this is kind of the same thing here with the arrow here. I'm going to the JSON object first, and then I'll go inside and extract the text from within. Of course, if I need a number, I need to then cast that to the number, but first I need to get the text. Yeah, okay, I'm not going to show you the length because the length is obvious, it's just going to give me a number, okay? Good. Now, another way of inspecting stuff is using a path. And this is, again, something that they run out of symbols, as Ilya was saying. This is a path to get a JSON object, and this is a path to get what is inside the JSON object. At least you're seeing a pattern here to identify and to remember, should I use 1 arrow, should I use 2 arrows? And a path here, you can think about, I'm from Chile. In Chile, all the cities were built like 300 years ago, and they were built after learning from how difficult it was to have streets going in all directions. So that all the streets are like squares, so you have like blocks. So for me, this looks like a path in a street. So that's how I remember there's a path. So to the left side, an object. And then here, the funny thing is that you need to have an array of text. So the array is going to look like this. So if I go to the object, I can go inside the bands. And inside the bands, I'm going to get the element number 1. It's not the first element, it's the element number 1. Okay. Same thing with this one. Whereas this one is going to give me a JSON object, this is going to give me text. So let's try it out. Oh, I didn't prepare this one. but probably I can do it like this. Select, and then I set, I have an album, which is my object, and then I have a path. Yep. And then, well, let's look at the tracks. So I said that I need to have an array built as a text. Yeah, so this is exactly the same thing that I was doing before, but instead of saying, give me the field, I just did the path. The good thing is that here I can say, like, give me the element number 1. So I go inside and extract only the particular one, which is the number 1. Now you can see that that's the second one, because you can actually have number 0. I'm going to get back to this in a minute, but this is how you build a path. Yeah, this, remember, is a JSON object. If I really want to have this, the text extract from within that object, I add another arrow and I get text without those complications of parsing the double quotes and stuff like that. Yeah, actually, the more that I do this, I like it more. I think support for JSON is super cool. It's just that it has ugly symbols. The symbols are terrible. Okay, so that's for path. It allows you to go inside the stuff. Let's get back a little bit about types. Yeah, I think this was just exercises about types. Let me see, for instance, here. I'm going to show you what happens if I get this. It's going to be JSON-B array element. Yeah, so this is a JSON object. It doesn't have the parentheses, it just have an array. And it has an integer, a Boolean, and another array with an integer and another Boolean. Yeah, and I'm only interested in the type of those stuff. And it's all JSON-B. So this is one, which is a JSON-B. This is another JSON-B, and this is another JSON-B. Yeah. So what if I do here elements text? Well, everything is basically text. Yeah. So that's the thing that you need to kind of understand when you're working with JSON objects. Either you get the object or you get the text, and then you need to do something that you need to do with that particular text. Now there is something cool here. Then instead of doing PG type of, I can do JSON-B type of. Aha. And why this one doesn't work? What did I do? JSON-B type of, and says
because it should be PG type of to return type.
No,
type
there
of,
is a JSON. There is a JSON-B type of.
Okay.
Or is it JSON type of? No, wait. I do have the experience. Maybe this one here. Oh, because I put text, of course. So it was JSON-B type of, and I don't want to get the text. I want to get JSON-B objects. Yeah, that's it. Okay, good. Sorry. So because I was filtering everything into text, I didn't need to have the text extracted from within the object. I need to pass the object so that I can see what is the type of the text. So this one is a number. Good. And this is a Boolean. Excellent. And this is an array. Yep. Oops. It's an array. Yep. So that's why the JSON-B type of gives you information. Let's try with another one, a little bit more complex. So this is a JSON-B object, which contains an array, a little bit similar, but then I'm going to add another object like this. And I'm going to add a towel because towels are very useful. So actually the type is not text, it is string when we are talking about JSON types. So you have either a number, a Boolean, or a string, and then those can be composed within arrays and within objects, as I did here, which keys and values. So objects has keys and values, arrays have just something inside, and the other ones can be, the values can be number, Boolean, or strings, which are text. Good, that was a note on types. Okay, let's modify some JSON objects now. Okay, so because I've just been inspecting JSON objects, I want to change some of the things, change values, add stuff, and things like that. So I'm going to go very briefly with this one. There are only 2 operations that I know about modifying JSON objects. There might be some more, but these 2 are enough to start. Yeah. One, it is to concatenate an object in this case, I click with another object and to subtract something from an object, which is subtract a field. This one concatenates an object and this one subtract a field. How do I remember these two operators? With this emotional icon, emoticon, this meh. It's like, you see like a two pair of eyes and a mouth like this. And this is how I remember the operators. I always try to find some ways of remember. Then the problem is that you don't remember how you were going to remember the stuff, and you're kind of in a problem. But the good thing is that we can add stuff to an object and we can remove fields from an object with these two operators. If you want to change the value of an object, what you can do is to remove that field and add an object containing the same field, but with a different value. Okay, so let's get back to it. Here, so let me show you a pretty representation of the object again. Yeah. First of all, you see that I changed the way of getting the same object. Instead of doing now album containing an object which has a key value ID and the value of the ID, now I do it. Give me the text extract from within the object and the field ID, and then I compare that with text. So this is a way of comparing text with that. If I do one arrow here, let me do it with one arrow. Can you try to guess what is going to give me this?
Have error, right?
Yep, error, because it doesn't know how to compare JSON with the text. Yep, so I need to get the text and then do the comparison. So you see I have ID, year, album, level, artist, track, and secrets. And metalizer, which is the pathological meta collection sacrifice. It always have a funny tag added to the albums. So what I'm going to do is I'm going to add some rate to this album. So I'm going to say that this album is good. I think it's a good album. It's not awesome, but it's good. Yeah. I update it. Okay, good, cool. Now, if I go to the same representation, I can see that it's where's my rate? Here. There is no order guarantee here. Yeah, I just know that it's going to add the field, and then I know that I can search for it and I can find it. So I added now a field inside the object. Good. So if I get that query here, where was the query? The key is here, this one. You can see that everybody has all the keys except for one that has a rate. Yeah. So that one has the rate now. That's how you have the dynamic objects actually. Now let me remove the rate. Oh, that went too fast, sorry. So I just do album is equal to album minus that field. Yeah, and I pass a field as a text, and then I update it. So if I go again, this all the values are exactly the same. So I remove that one. But let's see. Let me say that first I said that it was good. Okay, and then I said like, well, actually, after listening to a bit more to it, I think that this is actually not just good. It might be very good. So let me remove the rate, and then let me concatenate it with rates. Very good. I don't know whether this works, but okay, it does. So let me get the information about that one. This one here. And I can see that my rate is very good. Okay, so that's how you change the value of a field inside a JSON object. You remove the field that you want to change, and you add a new field containing whatever you want to have.
But there is also JSON be set, right? Function JSON be set.
But then you need to remember more functions.
Yeah, sure. And it also has issues with nulls.
It does? Okay.
Yeah. I recently had a problem with it. So
I see.
That's, yeah, it's so many functions, right?
Yeah, but it's good to know that there is another one, because I concatenated these two, and that works. But let me see if I remember that, remove that one, and I try to remove it again. Okay, it doesn't complain. So like, okay, it's fine. it doesn't have it, so it's good. Okay, so this one is solid, and at least in that sense. Good. So that's how you modify JSON objects. Add fields, remove fields, or change the value of a field by adding and removing, or using JSON-B sets, as you mentioned. Cool. All right. So I show you that all of the objects has exactly the same amount of fields. So I could argue that this could be a table. Yep. So can we convert the JSON to a regular table? Yes, we can. The question is it a good idea or not? If I get back to the first original example that we showed, the attributes, I don't think it's a good idea. In this case, yeah, I think it's a good idea because you have all of the objects looking at the same. The other question is, does it gent? So if you are a fan of metal music, you probably know this question comes a lot. So these are the albums. They all look the same. They have the same structure. So let's convert this album from JSON to columns. So we create a metal albums table with an ID which has a primary key. And this is the important thing. I can have primary key if I convert it into a column. Yeah. And then all the other things is going to be text because in JSON-B is a string. This particular one of tracks is actually a text with an array. So it's an array of text. And this one, which is secrets, I'm not going to split that one into multiple things. I know there is a JSON object here. So I'm just going to let that one to be still a JSON object because it could be anything inside. Yep. And the metalizer, which is this tag they put, is just text. So how they convert it, taking advantage of the primary key here, I'm going to insert into that metal albums, yeah, the new type table that I have, the result of this select query. The select query goes as follows. I do have a metal JSON here, B, which is the one that I'm going to have with a lateral join. The lateral join, it took me a while to understand what it does, but it's actually a cross-reference between what is at the right side to what it is here. So in the metal JSON B, I have a field, which is the only one, which is called album. So from this lateral join, I'm able to refer to this album here to what it is found here. Yeah. So what I'm going to do is I'm going to pass the album to this function JSON-B populate record. So I'm going to take the JSON album, I'm going to populate this record, and the record is the type from this table. And I'm passing an object which is just null cast as if it was metal album. So this is going to give me a record with the right signature. And I call this T, and then I get this T dot star. So this is how I do it. So let's do that. Running out of time, but I think we're fine. If you
we have time, no problem.
Yeah, okay, good. If you see, I don't have more tables, I have only these two. And then let me create my table here. Yep, so I create my table. Fine. Primary key, everything's good. And now I'm going to copy exactly the same code that I have, which is to insert into metal albums with that lateral join here, which is passing that album that belongs to this one, and with this signature as record. Now I need to look surprised because, oh, this is going to fail, and say, oh no, why did it fail? So I'm going to fix it, no worries. The thing is that I have a primary key here, and I did find some duplicates that violates that constraint. So that means that when you have a JSON object, the downside is that you don't have guarantees like having a primary key. So that's why some of the stuff you really need to benefit from the relational model. The relational model is very good for many, many things, especially for keeping things in unicity and stuff like that. So in this case, it's complaining that I have actually this key already exists. So I have an album that is either duplicated or is duplicating the key. So it's not going to let me insert that. And I can start cleaning up the JSON-B stuff and all the things, but that is going to take too much time. So what I'm going to do is that I'm going to do the following trick here. I'm going to put this query here. Select distinct album from metal JSON-B. So this is going to remove all my duplicates. And then I'm going to use that one for inserting. Yeah, so I'm showing you CTEs now, one small one. So this is the new metal JSON B, which removes duplicates. This one doesn't remove the fact that I have the same the same ID for 2 different albums. I'm trusting that the fact that I just put albums duplicate, and it was a mistake from me when I copied the files from the directory into the metal JSON myself. But I didn't have any way to do it because, I mean, JSON B doesn't have primary keys. So what I did is the only difference here is that I do it from metal no dubs, no duplicates, which is the one that I got from the CTE. And now it works. So you can see there are 9,126 files, whereas in the metal JSON, there were something like 500 or something, like 9,500, yeah. So there are like 400 duplicates. But with this one, I got rid of those. Of course, if this table is very large, this is really a problem. But at least, why did I keep the exercise like that? Is to show you the difference of having a primary key or not, which gives you other guarantees. But you can convert JSON to record. All right. So a note now on Postgres array versus JSON array. A Postgres array has an array of values that are all of the same type. Postgres is very good into giving you certainties about type of columns and all this stuff. Whereas in JSON, it doesn't matter. You can have anything. JSON objects, numbers, Boolean, strings, or arrays, which contains other JSON objects and all this stuff. So that's the main difference. So if you need to have a dynamic array, use a JSON array. If you need to have something more structured and all of the same type, use a Postgres array. And the other thing is the indexes inside the array. In Postgres, it starts with 1 and goes to n, which is the size of the array. In JSON of arrays, it starts from 0 and goes to n-1. Why do we do that in 2 different indexes? Well, because Postgres is, remember, PostgreSQL. So we respect the SQL standard. This was a statement that we do. And because we're very good at respecting standards, not like, let's do whatever we want to do. No, we respect also the JSON standard. And the JSON standard says that arrays start with 0. Yeah. So, okay, it's not our decision, SQL standard decision, JSON standard decision. We just follow and do it in the best possible way. Okay, so those were the indexes for the arrays, but what about search indexes? And this is time for gin. So you can, that's why I have a black bottle here, because you cannot see what I'm drinking. Okay, so gin indexes are the inverted indexes and are generic. So we are very good for JSON objects. Yeah. This might not be the best way of indexing the ID, but oops, I click again here. But I want to index the object because it can contain anything here. So remember that I have only one arrow here, one head of the arrow. So that means that it's the object that I'm indexing. So when I'm indexing an object, I prefer to use the gin index because it's going from the inside to the outside. It's more useful when you have it for tracks here. Yep. So because the tracks is an array, and the array is going to go inside the array, and then it's going to build up the index from outside, not like a tree. So that's the way of doing it for JSON fields. So you can index stuff with gin very well. Of course, you can use B-trees, but you do have a little bit of less guarantees because when I do this, I'm getting a text of the value of the ID. But if I have an array there or a JSON object, I'm going to just get a text representation of a JSON object, and then you get all those complications. Yeah. So you better use a gin because gin is going to index correctly everything inside. Yep. So that's about it, and it works. Yep. So remember, be careful about the fact that you have to do here 2 arrows here if you want to do a B-tree. Yeah. Okay, so how do you search? I'm going to refer now to this index here, the gin index here. If I search like this, what I'm saying is that I want to know the object that is contained by the album so that I can get the values here, which was the first way that I was doing the search here. This one is going to work, it's going to give me the result, but it's not going to use the index because I didn't index the album, I indexed the ID of the album. Yeah. Let's use this other one then. This one is going to be using an index, but it's going to be using the index only for the text values because I have here a text representation of this one. So if I want to use that gene index that I created, either for the tracks or for the ID, none of these two is going to use that index. So if you do explain analyze, it's not going to work. But this one is going to work. So what I'm going to do is that I have an object here on the left side, which is the album ID. Yeah, the ID is this one returns an object, remember? And this one is going to be, you see, this is a string as a JSON object because it's in between single quotes and then double quotes. So this is the way of searching that this one is contained inside this one. Yeah. So believe me, this is the one that works. If I do the execution, this other one is going to give you like a 16 milliseconds for the execution in this particular case. And this one is less than a millisecond. So the index are really used. Okay, but something more interesting, I think, is the path queries. Yeah, just going to give you two examples. So the path queries is also something funny in terms of reading this stuff. What we're going to do is that we're going to select the artist and the album that contains songs which the word pandemic. I didn't want to put pandemic or pandemia because I don't know what they're using. Okay, so pandemic is enough. So I'm going to get the artist, the album, and I'm going to get all the tracks. Yeah. How do I get all the tracks? I'm going to have a JSON-B pretty representation of the album and the tracks. Yeah. So I get the object, remember, get the object here. And the way to filter is the following. Again, we go back to the lateral join, which means that I can cross-reference from this part of from the objects that are inside this table here. Metal JSON-B, it has an album. So this is why I can refer to that album from this part of the lateral join. So what I pass to the JSON-B path query is the JSON-B object, yeah, and then I'm going to pass the query. The query has two symbols in this case, which is the $sign. The $sign represents the object that I pass, in this case, the album. And with the dot, I can go inside whatever it is there. So I'm going to have the tracks that are inside this album are going to be filtered by this query, which is that this part here, the tracks, is represented by this @ it looks like a regular expression, which is pandemic. Okay, so everything that has a pandemic inside is going to be sent as a result. It's a little bit of a long query, but the more exercise that you do with it, the better that you get it. And people which are more familiar with this are going to read that very easily. So I get the query here. Boom. So I get the artist, the brutalizer's consolation, the desiccated love, and they all have a track which has a pandemic, at least in the whole list of tracks. Yeah, pandemic. They actually all use pandemic. Okay, so that's how it works. But I don't want to have all the tracks. All the tracks is too much information. The only thing that I want to have is the particular track that is using this regular expression. So what I'm going to do is that not using it just only for the where clause, it's not the where clause, but the join clause. But I'm going to use it also to display. So I can filter this search path also for displaying the information. I already get the object, but instead of showing the entire value of the array, I'm going to parse that array with a path query because that's a JSON object. So I can do whatever I want with that. I can do with other JSON objects. So I pass, instead of passing the album, what I'm going to pass is the album and the tracks inside. Remember that you have to pass the object. So I have an object here. So this is an object. How am I going to pass that when I need to have this special notation to say that I'm going to go through all the elements of that array, and then there I'm going to apply exactly the same regular expression. Yeah, so it's not just for filtering out from the search query, but also for filtering out from the display. So in the display, I'm going to filter those that I'm interested. And then it's much faster. I get this output. Yep. So yeah, how much time does it take this? It takes about 300 milliseconds, and I get all the songs here. Okay. I don't know whether this is going to really help me, but let me create the index that I had there for the album tracks. And then let me repeat the query. No, it's about the same. So it's not using that particular index, the JSON path query. Good. Now, the good thing is that instead of using the same regular expression both cases, I could say like, okay, search for pandemic, but then once you get all the results, I want to filter by something else. So let me search for, what could be AG. Yeah, that seems to be more than one. Okay, so then I filter out in the display something different. So I did it not in the where clause, but in the representation. So I get pandemic aggression, pandemic agony. Hello, Mr. Aggression. Why did I get this one? Oh, because this is one of the tracks that appears in an album that has pandemic. Yeah, okay. There you go. So that's the way of using the path query. I think it's very powerful, really cool stuff. It's just the notation is very difficult to follow, but once you start getting some patterns, then you can do it. So what about primary keys for JSON? Again, you could use unique index. So this is one thing that is interesting. You can create a table the same way as did, and I can create a unique index with metal artist ID. And this is going to allow me to insert things that are not duplicated, but I could put actually whatever I want here on the ID. I could put a Boolean, I could put an object without that one, and it's still going to pass because it's a valid JSON object. So it doesn't really work as a primary key. It's a unique index, but it's still not a primary key. Yeah, you cannot refer it either as a foreign key and stuff like that. So yes, you can have unique indexes, which helps you, but it's not a primary key. Good, some closing words. JSON PostgreSQL, oh, actually JSON-B. I think, I mean, people in the US, I mean, Nikolai, probably you living there, you have noticed this. They use awesome a little bit too quickly, and then everything is awesome. It's like, how was your coffee? Awesome. Okay, fine. But in this case, I think it's really appropriate word for JSON support in PostgreSQL. I think it's awesome support for JSON. Yeah, and the implementation is JSON-B. Very useful when you have dynamic data or what is called schema-less data. And especially it's good when you balance your design between regular columns from the relational part with JSON. And because of that, I don't like that much the schema-less word. I would like to say schema freedom. Freedom. So this one gives you a lot of dynamic way of designing your databases. And because of that, you can forget about this horrible entity attribute value pattern. I really don't like it. It was a good.
Why?
Because of this very long column that it is very difficult to partition even. And all the attributes of one single object which are referred to are spread around this vertical column. That's why I don't like it.
And joins are always needed. I agree with you. Right. And performance is terrible. In all my benchmarks, it was even 15 years ago the same. It was terrible always. Yeah, at large scale. So AAV, no, please no.
Yeah. Right. It is a workaround because of the limitation of how relational databases work. But the fact that this table, I mean, we try to partition it, and then you partition it for some of the queries, but then it doesn't fit the other queries. And yes, okay. So, but now you have JSON, so you can do it with JSON, and I think it's very, very, very good. Use indexes, use path queries, and definitely use JSON-B. That would be my closing words about this JSON and Postgres. Oh, the API. Yeah, I forgot. So you have this API thing that is the in the slide that I show you that you can go to the URL with the API, and then you get a random album. Well, in Postgres, it's very easy. You just do PSQL headbanging, and then you say, okay, give me a select album from metal JSON-B ordered by random limit 1, and then I parse this with jQuery. But I implemented the API. Cool. Yeah. That's it. That's my presentation about JSON. I hope that it was useful, and it opens you some doors to start exploring JSON, and especially in which cases you want to explore JSON.
Good, thank you. There is a question in chat about indexes, back to indexes. You showed, of course, you said many words about Gene, and you said some words about B3. But question is, what is better, B3 or Gene?
Yeah. So in the case of here, in the case of tracks, which contains an array, I will go for Gene, because if we have multiple words inside which are going to be repeated multiple times, you can have actually your domain of things that are going to search inside the values of that array. Is much better to have it in a Gene index, which is kind of the same reason for using it for arrays in Postgres itself. Yeah, and actually, if you have some concatenated stuff inside, it's also going to be able to do that search. But if you have a value like in the ID that you know that the way that your application uses the JSON objects, even though you don't have the guarantees because you don't have the constraints there, you know that your application is always putting text there or
number, right?
Or number, yeah. Then use
Scala.
B-trees. Yeah. Then use B-trees.
Interesting, I would go with B3 if for like I know that it's different, definitely number, for example. And while you explained this, I thought if you create not just this double arrow but also convert it to integer 8, for example, this index will serve as a constraint as well, because I won't be able to insert a JSON value which has something not number in ID.
Oh, because it will violate the index.
Right. It's like kind of constraint. So
restricting
our freedom a little bit. Yeah.
Yes.
And if it's unique, as you showed on another slide, if it's unique and like it's kind of like something, some small constraint already there.
Yep.
But yep. I think B3 will behave much better in terms of performance than Gene if we deal with scalars.
Yeah. If you deal with scalars, definitely go with B3s. But if you deal with things that can be contain other stuff like the secrets part, then definitely use Gene.
Right. I also I have a sub question later. Not interrupting.
What I want to say is that if you have a situation like this one, that you want to have actually a primary key for the ID, then I think it's better to create a table not with just a JSON object inside, but with 2 columns. The first one is the ID, and the second one is your JSON object that contains the whole stuff. And then you can just have a column which is a primary key and immediately a B3, and then do the JSON for the JSON part. I mean, if all the objects need to have one field, which is the ID, and it have to be unique, then it's a column to me.
Normal primary key, right?
Yeah.
Also, if you do go with this, like convert it to text with using this double arrow operator, and later some another query also converts us to int, this B3 index won't work because it expects exactly the same expression as used in index. Any deviation at index doesn't work. Unlike with Gene index, which is very flexible, right? Can we return back to that first slide about indexes? I've noticed that here you decided to put not the whole album value, but only tracks. But we could put whole value there, right? And still have index working. So you reduce the value to have a smaller index size here, or what?
Yeah, because I wanted to just search for tracks. That was the only reason to do it. But if you do it like this,
this name already there.
Oh, the
index name
index.
collision. Yeah.
Let me just call it album. Yep. So this is going to index the entire thing. Yeah.
Right.
Does it work for search?
Power of Gene, right?
Yeah. So, so you can do that. I mean, the thing in this case, I just wanted to have the tracks because I knew that I was going to do some search on the tracks and get some information like words used by titles of the tracks and all this kind of stuff. So I want to have that particular one because it was being used for some of the queries.
Yeah, our audience continues pushing us towards indexes discussion anyway. So like the next question is, what is significance of JSON JSON B path ops op class for gene index. So this is modifier. We can strip the information about structure and have only key values pairs, right? So like the index size will be much smaller, right? And we will not all queries will be supported by such gene index, but like if the answer depends, right? So we need to understand our workload first of all. Of course, this is kind of optimization.
Yeah, but also your data. I mean, your data comes like this from the application. So if you start splitting this into just key value pairs, you will need to kind of flatten this as well, which is in. I couldn't get the code of this stuff, but my understanding is that these kind of things are referring to like sort of foreign keys to global identifiers, so that allows you to build these random generations of albums based on this secret. So probably this one is somewhere else as well. And yeah, by flattening this, you will get like tracks twice, one as part of the secrets and the other one just as the real name of the track. So you will have to call it like secret underscore tracks and stuff like that. And the fact that you have a JSON object, I think the beauty in it is that you can really nest stuff on it. If you really need to flat things out to make it more efficient, probably you're going to start using more relational features and having more normal columns on it to work with it.
Yeah. Anyway, with operator classes, we just need to understand our workload and see which operators we need and expect what we will need in the future. This is always the hard part, right? Because maybe we will need flexibility tomorrow, but in general, a gene index is quite heavy, right? And also this fast update feature, also sometimes annoying when you have a lot of writes. Default size is 4 megabytes. Sometimes vacuum is quite lagging, and we accumulate a lot of. It accumulates a lot of information, and sometimes we have issues where some queries are timing out and so on. So it's kind of like it requires some understanding and tweaking. So gene index,
I agree on that.
It requires maintenance, right? So that's why B3 is a good thing still, like because it's
so
very light.
If you look at my presentation on FOSDEM, I only have these two things here. And then I started to look at it and I said, well, actually, I shouldn't have used a gene index here. I want to still have the discussion. So that's why I added the B3 afterwards. So this part, it's only for this presentation that is being added, because I realized that the B3 was a better option. So I agree with you. B3 is, when you know what you're indexing, it is good. If you don't know, you need the flexibility and the power of the gene, then you just use gene.
Yeah, B3 is still a thing, right?
Absolutely, yeah.
What about array elements inside gene? Are they indexed as well?
Yeah.
Next question. Right. With normal gene, yes. Right.
Yeah.
Everything is indexed. That's why index size is huge by default.
Exactly. Yeah, and that's why it also helpful for these kind of things. I mean, you can just that's why we also pass the album, as you said, as you suggested, just pass the album, not pass album tracks. But this one has things that are inside as well, so it's also going to index the whole thing.
Yeah, in my experience, gene has a big issue, very big issue, which is not solved yet, unfortunately. And this issue is that when you need various kinds of searches, very often you need also to order by, for example, ID or timestamp, created at timestamp. You want to see like fresh results on the top of your results set. And this means that you need to combine like this JSON data with some another column, which is scalar, numeric or integer or timestamp. And you have B3 on there, you have gene index here, but they cannot play together. They cannot be used for a single index scan. So Postgres planner will always need to choose what to use, either to use B3 for order by and then to run filtering for JSON on the fly, or to use gene index to find all entries we need, and then to apply in-memory ordering and limit results at it. And sometimes there are edge cases which don't have good performance. We would like to combine these things, and there was an idea of different alcohol index, vodka, rum index, right?
Okay.
But it didn't work, unfortunately, because the index size was even bigger, and everything, all my tests showed me that I cannot use it in any production at all, unfortunately. And this was a big pity, because if RAM worked, we would have much more powerful indexing, even more powerful indexing. So this is not a solved problem. It's the same for full text search.
Well, basically, combining indexes in general is not an easy task to solve, and especially if you do not have things like index organized tables. So if you have a heap table and you need to scan gene and battery, you can imagine how slow it could be, just theoretically. So it's basically, I do not see an easy workaround how to do this.
No, indeed.
Yeah. So in Postgres, it's generally not solved problem how to have very good advanced either full text search or gene search on JSON and order by time. So unfortunately, like I would like to see it, but no. Many projects need it a lot. So yeah. But okay, it's about indexes. I hope no more questions about indexes, right? Okay, comment. Okay, comment. As far as I know, we will have to create one more gene specific to array element like album, tracks, JSON-B, path ops. Well, can you comment, Boriss, like about, do we need to create another gene index for?
It depends on the search that you're going to be doing, basically. Yeah, so or is it specifically about the secrets? Yeah, I would have to.
I'm not sure.
Play a little bit of this one. Yeah, but I mean, depending on the search that you do, every time you do a search, see whether it is using the index or not. And sometimes it's not using the index just because of the cost of doing the sequential scan is faster than doing the index. But I mean, yeah, creation of indexes or deletion of indexes because they're not used, it has to be always be inspected together with the queries that you're going to be running. Because
if you're lucky enough that you have such pattern of accessing data that you can cover your JSON field with proper function indexes, which could be created and used, and they cover your use cases, you're just a lucky person. So basically, if it works, it works. Yeah. Otherwise, you need to use Gene with all the limitations it has.
Yeah.
So this series of questions particularly target arrays, I mean JSON arrays inside the JSON value and gene. I think we need to follow up on this. It's interesting. I would like to play with it as well. Let's. I'm responding as well. Like let's follow up and have some examples and see if it. I think it should work. And it's always like everything is indexed. It should work, but we can comment later in comments and.
Yeah, if you need a data set, you can always go to this website. I don't know what is still available. I did this in January, and get JSON objects from there. I think those JSON objects has a nice structure of things that are nested, and they do have words that you can search for. And if you are okay with the vocabulary used by metal music, then it's fine. You're not going to be offended by warning. Sometimes there were some words that are could be offended, but that's a nice data set, I think, to experiment and to play if you want to have queries about JSONs inside another JSON, or arrays containing text, or arrays inside a JSON which is inside another JSON. So that's why I pick up this one, and because it's about metal, of course. Yeah.
Right.
So
okay.
Metal is still the game.
Good. We don't have questions in chat anymore. Maybe last question from me. If Ilya doesn't, Ilya, do you have questions? Like,
no. Take your last one.
Yeah, last.
I always have, but you know.
Like I don't know. It's like some philosophical question. What do you think about story of Postgres 15 and this like SQL JSON.
Yeah, I
Even
was a
more
little bit disappointed because it was looking promising in terms of what you can do with it and everything. But the fact that they discovered something that could be a real problem once it's being released, and it was going to be a lot more difficult to fix after the release. It shows in a way.
But it was removed from development branch of Postgres 16 as well.
That was odd. I understand that they removed it from the release of 15, but they removed it from the dev branch of 16.
Yeah, I don't understand this.
Odd.
So we just for our audience, we're talking about the big work which was done for Postgres 15 to support SQL JSON format, which is now a part of SQL big standard, and to bring us even more functions and syntax to work with JSON values and SQL context. But it was reverted, unfortunately.
Yeah. Yeah,
it reminds the story of merge, right? Like reverting merge, like same big when merge was implemented and then reverted, same like disappointment, right?
Yeah, but I mean, in a way, it still shows that when you have a new release of Postgres, the confidence that everything is being tested and everything is kind of being reviewed by a lot of people. It's still a high confidence. It might not move as fast as other engines. It might not allow fast, innovation, but the stability that you get from the database, it is something that in production you really need. So that's why you can tell people, like, I mean, why are you waiting to upgrade? I mean, you can upgrade as soon as you get kind of a very stable release, 15.1 or something like that, go in production. And as soon as you have 15.0, you can put all your staging environment in 15.0. It's not going to cost you too much modifications and maybe none at all. So that's something that I like. I mean, it's a price to pay that we don't go as fast as one would like, but at least it's very stable. Yeah.
Right.
That's why you have some companies that have their fork because they need to go faster because that's their demand. But I mean, there's a thing from the African culture that says if you want to go fast, go alone. If you're going to go far, go together. So I think that it's possible to go alone and forks and then try to get back. But if you want to move stable and so further away as possible, I mean, you need all this reviewing, and sometimes I mean we have to have this set storage of a lot of work that have to be taken away. But I mean, it's going to go back. Definitely.
If you don't want to perform 1000 merges alone, you probably need to go together.
Yeah. Okay, thank you, Boriss, one more time. It was great, interesting. I learned something new. Although I'm a big heavy user of JSON in Postgres, still I'm learning. Thank you so much.
Good. You're welcome.
Thank you.
So it's not only about heavy metal, just heavy JSON as well.
Heavy JSON.
Thanks for the invitation. I mean, it's a really an honor and a pleasure to be here. I mean, you guys are doing very good stuff in Postgres TV, inviting very, I mean, not because I'm invited, but also all the people that was invited before me. So very nice speakers, very nice subjects. The regularity that you guys have is also very important to the community. Providing all this content is a very good thing. So
glad to hear. Thank you.
Yeah, I'm not going to be surprised. It's going to be used as a typical source of knowledge. It's like, I need to know about this. Oh, check this chat I was given.
Right.
Postgres TV.
Exactly.
It's kind of one common source. It's going to be very useful. So thanks a lot for that work. It's very important.
Yeah, thank you. We appreciate.
And again, thank you everyone who watched us. As usual, please subscribe, like, and share. Share is also very important. It helps us grow. Thank you. Till next time. Bye-bye.